Today in class 11th, I am starting a new chapter called the statics. This year a question was asked from this chapter. So this is necessary to study it, and many times the question has been asked from this chapter. So this is an important one, keeping in mind the exams that like the NEET exam and other scientific exams also. So let us discuss about the statics. As the name suggests that the body is not moving, but this is at rest. So when the bodies are moving, then what can they do? Like we are having a number of examples in which the body is not is moving, but even it has a very good role in the turning of the bodies. So now we can define to this one. It is the branch of physics concerned with the forces that produce the state of rest, the equilibrium, in a system of bodies. So it deals with the bodies at rest. It deals with bodies at rest. The study of these are all the definitions to this one. The study of the system in which momentum does not change, whereas dynamics deals with the is called statics, whereas the dynamics deals with the change in momentum of the system Now there are so many examples of this statics. Examples number 1, a photo frame hanging on the wall. So this is like that. Suppose we are having this now photo frame. This is now your photo frame. And let's this is now photo frame and this is hanging by means of these are the threads. This is now photo frame. And this is the thread. This is also the thread. So this is hanging. You have seen in our houses that so many photo frames are being hanged on the wall by means of the threads. So this is also the equilibrium of the this photo frame. Opening and closing of doors and windows. So this is our regular way that daily we close the door and open the door, and that the door is not moving anywhere else, but this is in the same situation, but this is turning to some side with the application of the force. Similarly, turning of water tape, जो पानी का नल होता है, टोटी होती है, तो उसको क्या है अपनी फिंगर और इससे अंगूठे से उसको ऐसे ही रोटेट करते हैं या यूं रोटेट करते हैं. सो दैट इज ऑल्सो द रोटेशन ऑफ दिस वन. Turning of steering or handle of cycle. So now there are so many examples of this kind. There are many examples of this kind. So now let us first we will find that what is the moment of the force. moment of force. The turning effect of force is called moment of the force. It is equal to the product of magnitude, force and perpendicular distance of line of action of the force from a axis of rotation or some fixed point. So now this we can have like this: moment of the force is let's suppose this is a wheel and force is applied on it like this. This is the wheel, then it will have the rotating effect like this one. So this will rotate about this point O. Then this distance is now suppose D. This distance is now D. So this F into D, this is a perpendicular distance from this center O of this wheel. It is what the turning of wheel. Turning of wheel. Similarly, suppose you are having this some body, and let this is the axis of rotation, and this we apply a force on it. This we apply the force. This is the axis of rotation in this way, and let this is the point O. Now so much, and that we draw a perpendicular. This is now line of action. Now then this angle is your suppose theta. This angle is theta. This is now point P where the force is applied, and as a result this body moves in a about this axis. So now let's this distance. So we are having this what? OP. Now here, if we have here, then this moment is equal to F into D. Now here in this case, this is now suppose O dash, when moment is equal to, this is now force into what SP. What SP is equal to so much, and this is equal to F into what SP. This is equal to what? OP sin theta. OP sin theta. This is now right angle triangle. So this is equal to F, and this OP. This is now your R sin theta. So this moment is given by this R cross F. This is the moment. So this is the product of the perpendicular distance from the axis of rotation to the line of action of the force. And you can have the unit of this one. Unit. This is now your Newton meter. Newton meter. This is also called the joule. J. Joule. So you can have that this Newton meter and that the joule. This is now also the in the unit of that the work done or the energy. Dimensional formula. This is equal to M1 L2 and this is now your T minus 2. T minus 2. So now you can have that this direction of this moment of the force is always perpendicular to both. This is the applied force and this the perpendicular distance. So you can see that for theta equal to 0 degree, the moment is equal to, this is your FR sin 0. So this is equal to 0. And for theta equal to pi by 2. The moment equal to F into R. This is not so much. Then this is the minimum value. Minimum value. And this is now maximum value. So moment of the force is maximum when the applied force is perpendicular to the axis of rotation. So जैसे इस तरीके से है ना. This is not like this one. Suppose I apply the force in this direction. And this I hold here. Then this will rotate like this one. You would have seen the so many instruments that are used by the mechanic, like your screw and that the wrench. So they are always having the effect of that the force is applied perpendicular to the axis. Suppose this is this is to be tightened by means of the wrench, then wrench will be applied here, then the force will be applied like this, so that this turns in this way. So what we have, that this moment is maximum when the angle between R and F is 90 degree, and this is minimum when this is equal to 0 degree. So only we are having the benefit that this will be maximum when the angle between them is pi by 2. Now, the equilibrium. conditions for equilibrium. So now equilibrium, that now we can have the two kind of forces, one the translatory motion and second the rotational motion. So when the particle have the translatory motion, then the sum of the all forces acting on the particle must be zero. So that is for translatory motion. Number one, for translatory motion, thus vector sum of all forces acting on the particle. The vector sum of all forces acting on the particle must be zero. Must be zero. It means what? That this summation f, this is equal to 0. Suppose we are having a particle here and a number of forces are acting on this one. Suppose this is your F1 force and this is now for suppose this F2. This is now suppose for this F3 and this is now suppose for F4 and so on, like this one on this. So for this equilibrium, the equilibrium of this point O, the vector sum of all these forces must be equal to 0. This is what the meaning of this one. So we are having this F1 plus F2 plus F3 plus F4 plus this is equal to 0. So for n forces, we can have this F1 plus F2 plus F3 plus and so on. This Fn, this must be equal to 0. When the force is 0, it means that there is no acceleration in the system. The system has no acceleration. Have no acceleration. It means what? That acceleration is equal to 0. This is equal to 0. So this is for translatory motion. And second for rotational motion. For rotational motion, what we have? Let the vector sum of moments of the forces is equal to 0. It means what? That this summation torque, this is equal to 0. This is like this. So now suppose we are having this a beam. This is now suppose pivoted at this end, and a force is applied here. This is now suppose F1, and this is now a force. This is now suppose F2. This is a beam, and let this distance is x1. This is so much, and this distance is x2 from here. Then this will have the effect. This will rotate like this, and this will rotate in this way. So what? This is the anti-clockwise, and this is now clockwise rotation. So this is anti-clockwise rotation. Anti-clockwise. This is now clockwise. Rotation. It means that we have to this one in this way. That what we have this x1 into f1 plus x2 into f2. This is equal to 0. The moment of this force equal to the moment of this plus the moment of this force. That must be equal to 0. We are taking the vector sum. So thus we are having that when the body has the rotational motion, then the sum of the torque or the moment of the forces must be equal to the 0. So this is about the conditions for the equilibrium of a system when the number of forces are acting on it. So thank you very much.